Depending on the type of instructions that a CPU will provide, we can divide computers into two types. One is called complex instruction set computer. In shortcut, it is also called as CISC or CISC. CISC or CISC computers. And other one is reduced instruction set computer. It is also called as RISC or ISC. That is a shortcut. So we are going to classify the computers based on the type of instructions they are built with. Okay, and now which one is simpler and which one is complex, based on that we are going to divide it. So see all the points, characteristic. Now in CISC there will be large number of instructions. So right now you can see nearly 1000 instructions, at least from 200 to 1000. So there will be these many instructions present in a computer, right? So or at least close to 1000 instructions. So large number of instructions will be present. But the problem is, what is the advantage of these many instructions is they will be useful from the application developer point of view. But coming to the designer or the architect of the CPU who designs the CPU, they will unnecessarily add lot of headache. For example, if you want to test a bit inside a computer, inside a data part, instead of providing a special instruction for that, maybe you could use 2 or 3 existing instructions like masking, which is nothing but logical ANDing, right? But if you want to provide an instruction for that, then that instruction has to implement the other instructions as a part of it. Therefore, when you are programming, if you have a lot of instructions, that will be helpful for the programmer, but in order to design the CPU circuit, that might sometimes become complex, right? But still, if you look at programmer's point of view, they will go for CISC, right? And next one is some instructions that perform specialized tasks and are used infrequently. So even though an instruction is not going to be used very often, still such instructions will be implemented in these computers. Just now I said one example is testing a bit in the data, right? So even though we don't use it frequently, if you are going to provide an instruction for that, it is of course going to be used very infrequently, but still it is going to be provided, right? And next one is large number of addressing modes. So nearly 8 to 10 addressing modes will be provided in all these computers. So what is the problem with the addressing modes? Providing these many addressing modes is, in the instruction you will have to include the bits which will say what type of instruction this addressing mode is used. Now as the number of addressing modes are increasing, that length of the instruction will also increase, right? And the decoding will also take time. Therefore all of this is going to put on more overhead. But what is the advantage? Added advantage is, if you have more addressing modes, then your program can be translated faster. A high level language program can be directly translated to a low level program very easily. Okay, compilation is easy. And the next one is variable length instruction formats, which means we'll have 1-word instructions, 2-word instructions, 3-word instructions, like that. So depending on the number of operands provided and the type of addressing mode, the size of the instruction may be large or it may be smaller. Now the problem with such a format is, as I told you, when all the instructions are of different lengths, then the program counter has to be updated, but then the updation should not be uniform, which means sometimes an instruction may be 1 word. In that case you have to increment the program counter by 1 word. Sometimes an instruction can be 2 words. In that case you have to read 2 words and increment the program counter by 2 words, right? Therefore depending on the size of the instruction, many things will change. It is going to add somewhat complexity, right? And the next one is instructions that manipulate operands in memory. So you can directly manipulate the operands in memory. You need not get them to the registers and then do that, right? So if you have such a flexibility, it is going to add up to the speed. But the other thing is, you need to have this hardware circuit built in order to support such instructions. Therefore this is powerful, but it is costly, isn't it? And also it is, from the programmer's point of view, it will be easy. and next one is reduced instruction set computer. So this is nothing but these computers will have only the instructions which are strictly required. If a task can be done using the existing instructions, for that task no operation will be provided. Got it? So in this one, in order to with only the basic, what we can call is functionally complete, right? So the instruction set will be functionally complete, which means they will provide the minimal instructions which will be able to perform any function. And then if you want to implement a complex function, instead of providing an instruction for that, we use the existing instructions and then put them together and make a new instruction. So that is how this one is built. Now see this one. In the reduced instruction set, relatively few instructions, which means we are going to have only instructions which are very, very essential. We will not have all types of instructions, right? For example, we might never have instructions which will work on the operands which are present in memory. Instead, we load the operands into the registers and work on them. Got it? So by doing like that, we can decrease the number of instructions required. Such things, right? And next one is relatively few addressing modes. So they don't use a lot of addressing modes. Mainly 4 addressing modes will be used. 3 or 4 addressing modes will be used, and every instruction will contain only 2 bits to distinguish which addressing mode is used. And the next one is memory access is limited to load and store instructions. So we are not directly going to perform any operations on the operands present in the memory. If you want to perform any operations on the operands present in memory, you load it into the register, perform the operation and then store it back. That is how it is going to operate. And next point is all operations are done within the registers of CPU, which means we are not directly going to work on the operands present in the memory. And the next one is single cycle instruction execution. So what does it mean is, sometimes some operations, depending on the type of operation, they might take more than one cycle. So especially about this cycle time and all, we shall discuss it when we go to the topic of pipeline. For now, don't focus on that. I'll again come back to it. Okay. So what I'll take is, immediately after this topic, I'll take a small RISC computer with a limited instruction set, and we shall design it. Once we design it, I'll tell you what is a cycle and how it is. Okay. And the next one is fixed length easily decoded into instruction format. So in this one, we have all the instructions will be of the same length. It will not be like one instruction is of 2 words, one instruction is of 3 words, nothing like that. All of them will be of same length. Okay. So what is the advantage of that? We know exactly where one instruction ends and where the second one begins. So that will save us some time. And loading is also easy, and decoding is also easy. So whenever you decode, since the opcode is going to be very small, the decoding will be fast. And next one is hardwired rather than microprogrammed control. So in here, sometimes they go for microprogrammed control, and here they go for hardwired control. So what is the advantage of hardwiring is, it will be fast. Exactly what is the meaning of this hardwired and microprogram is, you will come to know about it now. In the next few videos, I'll explain it. So what is hardwired means, we are going to implement a CPU using the hardware circuit. Microprogram means we are going to implement the CPU by using microprogram. Microprogram means, okay, we shall come to it, then you'll understand. Or if you want to understand it in a vague manner, maybe you can think of it like this. So if you want to see, let us say if you have a register, let us say A, it has to be incremented by 1 if this is the case. In hardware, what happens is, we are going to build a circuit which will directly connect to the increment input of A, and then we inside this, the gates are going to create a 1, and then that 1 will be given to this, and this will be incremented. How will that 1 be generated? That depends on this instruction. When this instruction is given to this, we design the gates in such a way that 1 will be generated, right? And on the other way, this microprogram means we'll have a register, and in this register, for every instruction, we'll try to load a word right, like 00101 like this, right, and maybe, and each bit will represent a register. For example, this may be a register PC in PC increment, right. This may be a bit representing A, so A increment, okay. And now they will be connected to the corresponding inputs like this. So in order to execute an instruction in microprogrammed environment, we simply load a word into a register which is called as microprogram instruction register, okay. And that register will be giving us the number of corresponding zeros and ones, and they will be connected appropriately to all the registers like this, okay, all the registers and the other circuits. So depending on what this word is, they will be generated. And here we'll have the gates which are generating the signals. Here we have the word which is generating the signal. So this one is faster compared to this, because we have to load the instruction and then it will get executed. But anyway, this one is faster. The problem is this one is faster and that one is easier to implement, okay. So anyway, I don't know if you understood this or not. So what I mean to say is, here control signals are generated using the hardware circuits, and there the control signals are generated using a microprogram. So once I talk about the design in the next few videos, you will understand it clearly. So anything that you didn't understand here, you leave it. So simple computers, they use RISC, right, and complex computers, they use this one. They are costly but they are user friendly, and converting a program from high level to low level is easy in here. But here when you try to convert a program from high level to low level, sometimes your program will be very big. The reason is we don't have a lot of instructions here. So for any instruction which is not present in the instruction set, if you have to implement it, then you have to implement it using a lot of existing instructions. There many instructions are available, okay. So this is about the instruction set. We shall see the design, okay. In the design topic we shall see the hardware design. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.